Good afternoon to you all. Today we'll discuss about vegetation classification mapping. In this lecture, basically, I'll try to explain the various image interpretation elements, like how you interpret an image and classify a map. So to start with, vegetation is mainly characterized by their structure and function. And if you see the structure, it can be studied at different levels, like vegetation physiognomic level, biomass level, life form level, floristic or stand structure level. But the most important is vegetation physiognomy, because the physiognomy is nothing but the external appearance of vegetation. So primary recognition and determination of any formations and communities are done by basically based on physiognomy. Now, what is the role of remote sensing in and GIS in mapping? It's a very important tool for mapping and organizing vegetation data into different structural groups. And it is very necessary to understand the proper methodology for interpreting the forest vegetation classes. It's a very effective measure to manage forest and vegetation and other ecosystems. Both the visual and digital analysis techniques are generally used for mapping and monitoring of vegetation. Now, there is you have to understand the proper methodology for interpreting forest vegetation classes. So I'll first start with how you interpret a satellite image. So, what are the context of image interpretation? Basically, in everyday life we interpret many objects. But how remote sensing interpretation is different from our everyday interpretation, that we will see. First of all, remote sensing images, they portray images like bird's eye view images or in an overhead view. So the perspective is totally different from everyday in our daily life which we experience. And one more thing, remote sensing image uses radiation outside the visible portion of spectrum. So they not only use visible spectrum, in addition to that, they use the total electromagnetic spectrum. Then remote sensing images often portray the Earth's surface in an unfamiliar scales and resolution. This is how it is different from everyday experience, how you interpret a satellite data, or how you interpret different images, or how you recognize different objects. Now, to start with image interpretation is basically to translate images into information. So for doing that, first of all, the knowledge about the subject is essential. So suppose I am from forestry background, so my knowledge about forestry should be there. So familiarity with the subject of interpretation is very much essential. Second one is geographic region. Now, knowledge of the specific geographic region is also important while interpreting any image. I'll discuss it elaborately in my next slides, all these. And above all, you should have a knowledge of the remote sensing system as a whole to interpret any image or any object or identify any object in an image. Now, what are the strategy of image interpretation? There is a procedure that enables the interpreter to relate geographic features in the ground to their appearance on the image. Basically, what you are doing is like whatever you are seeing on the image, you are trying to relate this with the ground feature. For doing that, you should have field observation. So many categories of image interpretation are there. So one is field observation. The interpreter should identify the same object which are visible on the image to the ground to relate what exactly it is. And then one more thing is direct recognition. If you are very experienced, but your knowledge about certain areas is vast, so you can directly also recognize many things. But field observation is very much essential for image interpretation or identifying. I should say identifying different objects. Then collateral information, like non-image information, like from books, maps, we get many collateral information which helps us to identify or interpret an image, identify an object, an image. Now, while interpreting, while you start interpreting or before interpreting, certain things you should keep in your mind. First of all, you should have a knowledge of a study area. Suppose any image is given to you and somebody tells you like interpret this image. First of all, you should ask about the study area. Why? Because once you know about the study area of the image, immediately certain things are in your mind. Like suppose I say it's a coastal area. The study area, let's say it's a Sundarban area or it's a coastal area. So immediately certain things is in mind, is my mind. With coastal area, that means there will be mangrove forest. So I cannot expect alpine vegetation or temperate vegetation in a coastal area. So in vegetation, the classes or vegetation types present in that area, you know. So from a larger types of groups, you come to a narrow group when you know the study area. Then spatial resolution. Yes, the features depicted on satellite imagery is also is very much dependent on the spatial resolution of the imagery. Then season, yes. For forest studies, mainly for vegetation studies, phenological status of the vegetation is very much important, because if you are interpreting a dry deciduous area, and you have taken a dry season imagery, so you interpret everything as a non-forest area, because the reflection whatever you are getting is basically reflection of ground as well as the stems. So season is also important, and so also the physiography. Physiography has a very close relation with vegetation. So before interpreting or before starting interpretation of satellite imagery or while interpreting also, you should know about these four things: study area, spatial resolution, season, and physiography. This will facilitate you to interpret in a better way in an image. Then, when you do interpretation, you should have your own classification scheme. This classification scheme are again objective driven, and then controlled by mapping scheme. Of course, suppose my aim of the aim of my study is to study the forest cover of the whole world. So it is forest cover of the area. So I will not go for forest types. So basically I may restrict myself to forest, because it's a larger area, I will restrict myself to forest and non-forest. So my classification scheme will be this. But again, classification scheme is totally dependent on the objective of the study, what the purpose of mapping. Here, both the spatial and spectral resolution of the image plays a very important role in discriminating the features on the earth, and hence they play a very significant role. And for uniformity also, if you are working in a sub-regional, regional, national level, you should have a standard scheme, classification scheme before starting your interpretation. Each country has developed its own method of classification. It is advisable to use a hierarchical classification system. So one classification system I'll just show, which generally is followed. There are different levels. Level 1 is broad types. Then level 2 and level 3 it can be level 4. But again, this depends on what is your objective of the study. If my objective of the study is only forest cover monitoring in area, I can go for level 1. If it's a bigger area, I can go for level 1 classification. If my objective is to study the biodiversity in an area, so I should go for level 4 classification. Now, to address the level 4 classification, I should have this kind of data which facilitates level 4 classification. Otherwise, I will end up in I design a classification scheme which is addressing level 4 classification, but my data doesn't allow you to go up to level 4 classification. So the objective as well as the data is a deciding factor in this kind of making the classification scheme. When you classify vegetation using remote sensing data, first of all, what you do, you try to identify the plants for the vegetation in a very large area, like macroclimatic zone. So first of all, you identify a bigger area. So these are forest area, let's say vegetation. Then you come down to like in next level, you can go for plant formations, like physiognomy, basal physiognomy, then subformation. Then you can go on like gregarious formations, then successions, or maybe anything. But again, here this will depend on your capability of data, which data you are using. Now I'll discuss visual interpretation, how you visually interpret an image. Then I'll again subsequently discuss on digital classification of an image. Now, visual classification or visual image interpretation is a very commonly used technique for mapping and analysis of forest vegetation. For doing that, you use certain elements. These are called image interpretation elements through which you interpret an image. These are tone, texture, shape, size, pattern, location, association, shadow, aspect, resolution. These are the image interpretation elements through which we interpret an image. Now, I'll show you a satellite image and try to explain all these elements in that image. Now, first of all, I'll show you image of is a landscape data of 14th February 2010. Now the data, the area is Boon Valley. See, I already mentioned like whenever any image is given to you, first of all you should ask about the area. So the area is Boon Valley. And the season also. The season is, the month is February. So this is very important when I am classifying a vegetation. So this is in the month of February and this data, same area in April and same area in October. So let us start with October maybe. No, this is a false color, standard false color composite. That means all the red colors, so reddish tones, wherever you are seeing, it is vegetation. So all these reddish tones, these are all vegetation. These are all forest areas. These are all forest areas. All forest areas. These are agricultural areas. All these agricultural areas, and these are basically dry river beds. These are all dry river beds. This is basically urban area. Is Rishikesh town, and there are somewhere here in this left-hand corner. Now, this is October season. October season means just after rainfall, quiet season. So if you look at this imagery, this is hardly, if I consider only on vegetation classes. So here I will see here, these are all vegetation, this is vegetation. So it seems to be a same type. Another type is here, based on the tone itself. So based on tone, I can differentiate tone or color, I can differentiate it into 1 plus, 2 plus, and maybe n 1 plus here. Now same area, if I look at in February image, now look at these areas near the rivers. Here in these areas and here also in these areas, you want that get greenery. That means if I see in October, in these areas it is all red. Now what happened to this area? So if I interpret based on tones, that means it is a different class. Now whether it is forest or non-forest. Now in February, because I have seen the field, so field ground truth is very much essential for this. These areas actually, these are Dalbergias tissue and acacia tissue. So these are actually leafless. So these are basically riverine forest, leafless. Even these areas, leafless. So in February, these are leafless. So whatever reflectance you are getting from ground. So it seems to be a non-forest kind of thing. So what I want to highlight here is, if I am interpreting a deciduous area, I should have 2 season imagery. So that from October imagery, I can get the outline of the forest, and in using this imagery, I can differentiate like this moist deciduous forest or salt forest from this riverine forest. So this is based on tone. So this phenology plays a very important role. Now, there is another element called texture. Texture is whether it is a smooth texture or it's a rough texture. So suppose there is a forest which is open forest, so there it will be a rough kind of texture. But it is a very dense forest like this, or gregarious formations and dense forest will give you a smooth kind of texture. So using texture also you can identify different objects. Now, so I have talked about tone, texture, and shape, size. Now, one thing is here, this greenery. Now, if I have visited this field, so I know this is riverine forest. Now, same tone is available in this area, also, somewhere here, in this area, in here also, and inside this here also. Now, is it the same class? Then question comes again. So you need to visit these areas also where you have doubts. So in this area, this is giving same tone and same season. So basically indicates the same forest type. But is it so? So after the field visit, I could confirm that this is a teak forest. It is giving same tone because teak plantation is also leafless in that season. So how do I differentiate between teak and riverine forest? So this is there is one element called association. River and forest are all are associated with the rivers, so they are found near the rivers only. Now, I cannot expect a river and forest in between forest here or somewhere here. So again, association plays a very important role. Though the tone, texture, size, shape, everything is same. But because of the association, I can differentiate this from this. Now you can see this small strip. This is the airstrip or the airport of the Jollygrant airport. Now this is different from the other. Even if the tone here and here is same, but this seems to be a man-made object because it is a definite shape. So man-made objects have definite shapes. Okay. You can see here also there are plantation blocks. Even in forestry also you can identify plantation blocks because these are man-made blocks or plantations. The plantation areas also can be differentiated from the natural forest. Then another this thing is called location. Now, what do you mean by location? Now you can see here there are some spots here. There are some spots here. Now, if I give you a imagery of say Northeast India, you will get a similar kind of forest blanks and forest blanks. Now, in Northeast India, people practice shifting cultivation. These are basically because of those kind of things. So, but same, if I use the same interpretation key, I cannot classify these areas or this area as shifting cultivation areas because this is not practiced in Uttarakhand and Sedun Valley. So basically, what I mean to say is even in the tone, texture, association, size, shape, everything is same, but because of location, I can identify different objects. Okay. So here, when I am identifying any object, so it is not only one element, it's a combination of elements through which I am able to identify different objects. I am using tone, then texture also, then association also, location also. So it's a combination of different elements through which I am able to identify different objects. Now same area, if I look at the left hand corner here. Now if you see in October imagery here in these areas, so these are full of forest. Now, what happened if I go to February? It seems to be non-forest areas, and it increases further when I see April imagery. In April imagery seems everything as a non-forest given, or the signature is given, or tone which is shown. It is giving a tone of non-forest. Now, what happened to this forest? This is basically a dry deciduous forest. So April and May they are leafless. So basically whatever you are getting the reflection, these are all reflections from the ground as well as the stems. So again, so this area, it is only because of the phenological changes. Because of the phenology, I am getting different kind of tones in this area. So care should be taken when I am interpreting an image. Again, it is again driven by the objective. If my objective is to study, let's say, forest fire, I should not go for October imagery. I should look for an imagery where I can get forest fire. So till a month is good. So you can see a forest fire scar here and smoke also here. So basically, suppose I want to do the land landscape, so I'll go for maybe in this area February image and October image. In October image, I'll get the outline of the forest from this, and February image will facilitate me to identify different groups. Let's say deciduous forest, dry deciduous forest, this is a moist deciduous forest, basically salt forest. Then you have eucalyptus plantations here. Then you have riverine forest. Then there are teak plantations also. So the selection of imagery. Again, selection of imagery and the season and the proper season of imagery is driven by the objective. So if I am interested in land cover, I'll take a dry season imagery, dry and wet season. If I am interested in forest fire, I should look for imagery where you can get the forest fire. So this is how you interpret an image based on different image interpretation elements. Now I'll show some high resolution. This is a medium resolution image. Yeah? This is a high resolution imagery of World War II. Now you can see these are all fields, like crop fields. Now high this resolution of this is 0.5 meter and 8 bands imagery, World War II imagery. Now here you can see the patterns here. So these are all agricultural fields, some with crops, some without crops also. So it has a definite shape, size also, because I know the resolution, shape, size, and from the pattern you can identify this is a man-made thing. And in this is also clear, like this is with crop, these are with crops, crop field, these are without crops. Now again one imagery. This is again World War II imagery of nearby. Yeah? Now here you can see these are all agricultural fields. Now World War II is having a 0.5 meter resolution, and in these things you can see there are round things. These are all because these are all trees. But if you see here, the spacings are very uniform. So this may be a man-made thing. So this is basically orchard, mango orchard. Now see, uniform pattern is there. Then if you are spacing from this, you can identify this may be a, since this is giving a red stone, so it's a vegetation. Vegetation means it's orchard or plantation. So with field variation, and you can find out which species is this. Now here also you can say different types of, like one is here, this all are mango orchard, but if you see here, and this one, there are different stages of growth. Now here, since the plants are large, canopies are they have interlocked canopies, so you cannot identify a single tree like this. So these are all mixed up interlocked kind of tree canopies. Now here the age is lesser than this, so you can get individual canopies. Here you can see smaller things. So age wise, this is like this can be also exactly age you cannot tell, but at least you can say this is different from this is different from this. And since there is a uniform pattern, so it's a man-made thing, and it's basically orchard. Now come to forest area. Now in forest area also, see basically the tones are same. So this is forest. Fine. Now if you see this area, there is a block kind of thing. So this is basically plantation area here. This is a plantation area. So these are all natural forests. Again, it is a World War II imagery, 0.5 meter resolution, spatial resolution, and 8 band resolution. There are 8 bands. So here, if you see this one, this is a plantation block, which is clearly different from this. Even though if you see the tones also, it is same, but seeing this shape, you can say this is a plantation area. Similarly, if you look at these areas, now this is a part of this Gadwal image. Now if you see, there is a uniform pattern, and so this is basically terrace cultivation practiced in this area, and this is southern slope, this is northern slope. Again southern aspect, northern aspect, this southern aspect, northern aspect. So being warmer aspect, the southern aspect being the warmer, people cultivate this crop. So here you see these areas, these all are having crops, but you can see the terrace is clear. So from this pattern you can identify this is terrace cultivation. Then this is a typical urban area. You can see the uniform pattern, houses. So this is a typical urban area image. Again, World War II image. Now here if you talk of densities, canopy densities, if you see these are high density, you can hardly see ground here in these areas or high density forest. If you see these areas, these are medium density kind of thing, and here it is like open forest kind of thing or low density. So using a very high resolution imagery, you can identify, or you can stratify forest into high, medium, and low density very effectively. Now this is imagery of Gujarat. Now this is October imagery, and look at April imagery. These all are fire scars, like things. Now suppose I want to do vegetation mapping in this area, and if I am taking in April imagery, see, I will classify everything as non-forest here. So to classify this kind of dry area, you should have a two-season imagery, where now from this you can identify the outer boundary. And to see the extent of fire, you can take this imagery and outline, and you delineate this forest fire and calculate the area affected by forest fire. This is a ground photo of the area. So when you are interpreting any say dry deciduous area, you should go for two season imagery. Otherwise, it will be problem in the interpretation. Now these small things, if you see here in these areas, this is basically imagery of Northeast India. Now if you see these small curves, white patches, all these patches are shifting cultivation areas. All these small patches, the small areas are shifting cultivation. Again, these are location specific. Same scars we can get in maybe in a different forest area, maybe, but I cannot say it's a shifting cultivation patch. So or when Jumland. So here in Northeast India, as people practice this kind of thing, I can say these are all these shifting cultivation patches. But again, ground truth is essential for this. How you interpret? So what here I have shown that it is not only mapping, you can monitor also your area. Same area, there is again Assam Bhutan border area, Chardar forest area. So here if you see in 1924 the forest status was like this. So I try to delineate all the forest areas. Then in same area 75, these all things are delineated. So this is forest basically, this is non-forest, these are rivers. In same area, I have taken 1990 imagery and try to delineate the features. Now, if you look at from 1990 to 2000, you can see all these forest areas are converted to non-forest. So, and in 2000 to 2003 or 2009, all everything is clear. So if I compare between let's say 1990 and 2009, all these forest areas were converted to non-forest. So when I am doing a visual interpretation, it's basically I'm doing a visual interpretation, and so it's basically vector. I'm generating vector over this area. So suppose after 10 years or 20 years, I want to see the status of the vegetation or encroachment in my area. What I'll do, I'll overlay the vector boundary over this and modify the vector. So it is very easy to update the vector layers. Same in nearby area also, same thing was also done. Like 1990 or 24 it was full of forest, then 75. If you see here, and if you as time goes on, all these areas were removed. So again, if I want to see in 2014, what I'll do, I'll order 2014, same data, same resolution data. So it's a list 3, so I'll order list 3 data of the same area. And what I'll do, I'll this vector layer I'll overlay on 2014 data, and again I'll update the vector layer. So I don't want to make the map again. It is only updating of vector layers, which is very easy. Now, so if I see all the images, the main or the most important one is tone. Tone is the most important one, so as forestry or vegetation is concerned. Then comes the size, shape, texture, pattern, height, shadow, size, isolation. But only based on tone, you cannot classify all the things. You may classify forest and non-forest, but again it's difficult. It's a combination of different elements by which you can identify different objects. Now data selection is very important. And then suppose I want to study which data I should purchase, which data I should look for. Now data selection is totally dependent on the objective of study. Suppose I want to do, let's say, vegetation type thing, I'll go for I should see the phenological state of the vegetation. And suppose, and again, my data should be cloud free. Otherwise, everything will be on the cloud. Many things won't be visible in that. And snow cover free also. Then as I said earlier also, if I am interested in forest fire mapping, I should go for a season where forest fire occurs. So everything, data selection is totally dependent on your objective of study. So in general, the phenological state should be taken into consideration. Identical region, then land use space, cloud and snow cover should be taken into account while selecting Indian data. Now what should the proper season? There is a like humid, moist, evergreen semi-arid forest. It should be January, February. So the tropical moist is December, January. Then for let's say coastal mangrove vegetation, it is February, March, and low tide data. For main crops, I should not go for a rainy season data because all these coastal vegetation will be underwater then. So I should look for a data where mangroves are visible, maximum visible. So I should look for a February March data or a low tide data preferably. I should look for this kind of data. So these are the seasons. No, but again, based on your study or objective again, this is selection of data will vary. Now, once I have the data also, what should be my mapping skill? Suppose I am purchasing, let's say list 3. I am working in a list 23.5 meter. So my mapping skill should be 50,000. I cannot work on a 20,000. If I am using a list, I cannot work in 1:20,000. So these are different again. Like if I am using a 23.5 meter resolution, my mapping scale should be 1:50,000. If I am using a 2.5 meter, my mapping scale should be 10,000, like this. So mapping scale is again driven by the spatial resolution of the data. So this is all about like visual interpretation, how you visually interpret based on different object, like different image interpretation elements. You interpret different like land uses and our area. Now coming to digital classification. This digital classification, digital techniques, they make you use of the full spectrum information, and they avoid individual biases also. So the task of digital classification is to assign label each pixel to a certain specific class. Broad classification, if I go broad, two categories: there's supervised classification and unsupervised classification. Now let us see supervised classification. So supervised classification based on the prior information, the spectral characteristics, the classes, person trains the computer to generate boundaries in the feature space. So what you do, you generate training sites. Go to field and take training sites. Training sites of different classes. Then, so it involves 3 stages: training stage, classification stage, output stage. So what you do is basically you train the computer to generate boundaries in feature space within which each class should lie. So then each pixel lying within a class boundary is assigned to that class. So basically what I am doing is I am assigning training sites, and based on these training sites, it is classifying the whole imagery into different classes. Then comes unsupervised classification. Unsupervised classification, in supervised classification, as I said earlier, the essential requirement is a set of like training sites. If this is not available, or if such information is not available, then they go for unsupervised classification. Unsupervised classification, what it does, it makes a cluster of similar classes in a feature space. Clustering is done by applying suitable algorithms on the basis of spectral signature and generate spectral classes. And by ground verification, each spectral class is assigned to a class on the ground. So in supervised classification, you know the classes. So you give training sites, then you classify into different classes. In unsupervised classification, you classify the image first, and then you assign different classes. Now, so suppose I am doing visual interpretation or digital interpretation, I should quantitatively assess the accuracy of classification. This is essential. How accurate my map is? My map may not be correct in all the places. So how do I do that? For doing this, my classified map, which I have generated through either visual interpretation or supervised classification or unsupervised classification, it should be field verified. So the classified map has to be checked by comparing classified data with actual ground information. Like suppose I have classified this as sulfur. I'll confirm in field, randomly I'll confirm whether this area, any area, in that study area, whether it falls in the same class or it is misclassified to some other class. So this result of this accuracy check is a say M by matrix. Where M is number of classes. This matrix is basically called confusion matrix or error matrix, or you can say continuous interval. This confusion matrix enables us to understand the omission and commission errors. Now, what are those omission and commission errors? This helps to identify classes which are difficult to separate. Now, coming to commission and omission errors. Omission error, suppose there is a class X for which accuracy is estimated. Now, after the field verification, it is seen that it is classified as another class. That the sample is omitted from the true class and there is omission from the category. In case of omission, sample from other classes are misclassified and added to the class X. So there is addition in that addition to the wrong class. So this is called commission error. So there are another two terms. Producer accuracy is nothing but measure of omission error, and user accuracy is a measure of commission error. Now, producer accuracy it can be defined as number of correctly classified samples of category, let's say X, is divided by the total number of that observed. I'll show an example. I'll show how you do accuracy assessment. Then user accuracy is the number of correctly classified samples of category X divided by the total number of samples that are classified as category X. Now, I take a small example. Now, this is my classified map. This is classified classes. So I have forest, settlement, agriculture, scrub, water. Now, this is a reference data means from field. This is classified. So what I'll do, I'll take my classified map to field and I can do any kind of something. Anywhere, let's say I'm doing random kind of something. Anywhere I'm standing, I'm taking the number of samples. Let's say I have taken 88 samples in forest areas. So out of which, in forest class 70 is out of 88, 70 fell in forest and rest 5 in settlement, 13 in scrub. Likewise, settlements also out of 58, 55 are correct, 3 in forest. In agriculture, all 99 fell in agriculture only. So this is basically reference data means field after field verification. This is what I have classified. Now, if I want to calculate the accuracy of this image, what I'll do is diagonal things I'll add up and divided by the total here will give me the accuracy of this image. This is totally hypothetical data. What is producer accuracy? So here you say this is 70 by 73. So as I said earlier, the number of correctly classified samples of category X divided by the total number of that category observed on ground is producer accuracy. So 70 by 73, 96. This is the omission error of that class. And 70 by 88 is the commission error. Now, earlier also I told about omission error. Omission error is the class X for which the accuracy is estimated is classified as another class. And in commission error, so there is the sample is omitted. In other one, there is addition in the sample, commission error. So basically, you are getting overall accuracy of this map as well as the producers and accuracy of each class. So it gives you an idea of the mixing up of the different classes. Now I'll show you maybe an example of how you start classifying an image, or maybe this study I've done for Sundarban mangroves. So it was basically IRS 1D list 3 image was used and different classification techniques were used for mapping Sundarban mangroves. Now the main aim was to map the mangroves of Sundarban using IRS 1D list 3. So this is the aim, to map the mangroves of this area. So basic requirement first is I should order data, which is at least February, let's say February March data. Okay. And then I should make a methodology and a classification scheme and then start interpreting. So the data which was used is IRS 1D list data of 2002. Now these are all the non-forest areas. These are all mangroves, and you can see there are 2-3 classes, 4 classes of mangroves here, which could be delineated using a listed data. More than this, it was not possible using a listed data. So these areas are 3 small creeks here. There is open ocean here. These all are non-forest area. These are wetlands. So my aim was to use supervised classification, unsupervised classification, and visual interpretation to map the mangroves, or say land use, vegetation type land use in the mangroves. Now, what I have done is I am showing a simple methodology. So first I ordered satellite data. Now satellite data ordering or data selection is totally dependent on the objective of the study. So based on my objective, I ordered or I purchased list data of February of that same year. Then after geometry, radiometric correction. So I have taken only my study area using the Sundarban Biosphere Reserve. Using Sundarban Biosphere Reserve boundary, I extracted the study area. So, which looks like this. So, it's a subset of a bigger scene. Now, once my study area extraction is there, then I went for ground truth. Now, taking a hard copy of this and a GPS, I went to ground and see, there is, it seems to be the same kind of thing here in these areas. But this is certainly different from this, and these are again different from these. So what I try to do in field is visit some of these areas and try to see which vegetation is this. Once you are sure about this vegetation in this list imagery, so you can make out what these areas are about, and these areas also. So advantage of remote sensing is you don't have to go to all the places, because again your all those imagination elements will come into help. And these areas, again, you visit some of these areas and then identify which forest type is this. So after ground truth, then I need on-screen visual interpretation, supervised classification, and unsupervised classification. Of course, for unsupervised classification, we don't have to have ground truth of this area. So all these on-screen visual interpretation, supervised, these all these three things actually, this should be connected to this, also should be connected to this. So these three vegetation type land use map are created or generated. All these maps are again taken to field for field check or say ground check, and to assess the accuracy of this map, and finally I add the vegetation type map with certain accuracy. Now first method is on-screen visual interpretation. Now if I look at this area, then I could see I could delineate Abyssinia, Phoenix, mixed mangrove scrub, and acacia and other non-forest classes in this area using a list imagery. And the accuracy was very high. So at the end of this vegetation land use map, you can calculate the area statistics, so area under different classes. So here what I have done, a zoom view of this, see different classes here of mangroves and non-mangroves also. So accuracy in this thing was found to be very high, and the area under each classes also were noted down here. I performed like supervised classification. And same supervised classification also I could get 4 mangrove classes and casuarina and other non-mangrove classes and area under each class. Assume but accuracy again went down. And further with unsupervised classification it went down further. So in this area what I felt like visual interpretation was better than other groups, because if you look at these small areas, there is mixing of mangrove scrub, mudflats and other things. So there is here it was more control was there in visual interpretation, but in this one, because you have seen in this kind of thing, you know your area, then you are delineating small features, but in this there was a difficult to delineate. So main mixing up was in this area. That's why I'm showing this area only. So whatever it is, but basic methodology is like this. If I want to do vegetation type, mapping and classification, what I'll do, I'll order or procure satellite data which fits to my let's say objective of my study. Then I will do radiometric corrections. Then if I am not interested in whole area, I will take a district boundary or a state boundary, whatever my study area is. So using as a boundary, I'll extract the study area, and then I'll go for ground truth. This ground truth is very much essential for any study, like mainly for vegetation typing kind of thing. So ground truth is facilitated you to identify different classes. So you can go for different classification schemes which suits you. Then you do the accuracy assessment after field checking. That means you will take this land use transfer map to field again, and you will check the accuracy of this map, and ultimately you will get the vegetation land use map with certain accuracy, and then you calculate the different like area under or area specific area under different classes. So overall, to let's say, if I want to conclude this, the accurate and accurate baseline information on the status of vegetation is a prerequisite for sustainable development planning. The vegetation mapping provides an understanding on the vegetation distribution pattern, varying from broad vegetation types to specific categories in the landscape. This technology serves as a valuable tool for gathering information, time and cost effectively. Moreover, this data are offering many advantages over conventional methods and has been widely used for mapping as well as monitoring purposes. So this is all about how you interpret an image and how you classify vegetation and map vegetation in different categories. Thank you.